So this short talk is called Magic of Einstein E equals mc squared. So this video is similar to other videos I've done, but it's prompted by the fact that even though I've pointed out many problems with relativity, people that I've talked to are still impressed with relativity and want to believe it because they think the equation E equals mc squared comes from Einstein's special relativity, and the fact is it doesn't. Einstein creates the equation E equals mc squared by using magic. How does he get the equation? He doesn't tell you, so therefore he creates the equation by magic. So let's go into the details about that. So the relevant article is this one by Scientific American, and the question raised is, was Einstein the first to invent E equals mc squared? Now, saying you invent an equation is quite problematic, but let's ignore that. The article says no equation is more famous than E equals mc squared, and few are simpler, i.e. few equations are simpler than that. Indeed, the immortal equation's fame rests largely on that utter simplicity: the energy E of a system is equal to its mass m multiplied by c squared, the speed of light squared. The equation's message is that the mass of a system measures its energy content. Yet E equals mc squared tells us something even more fundamental. If we think of c, the speed of light, as 1 light year per year, the conversion factor c squared equals 1. That leaves us with E equals m. Energy and mass are the same. So that can lead to argument of whether you want to interpret the equation that way or not. E equals mc squared, how do you interpret it? People have come up with different ways of thinking about that, but putting that issue aside, and let's go on to the next part. So next the article goes on and says, according to scientific folklore, Albert Einstein formulated this equation in 1905 and in a single blow explained how energy can be released in stars and nuclear explosions. So when it says folklore, it's a bit of a folklore. It is sort of like mythology, and it's something that is probably taught in physics classes about this. So really much of science is about having myths and so forth. But anyway, it goes on and says, this is a vast oversimplification. Einstein was neither the first person to consider the equivalence of mass and energy, nor did he actually prove it. So note the word, he didn't prove it. So he didn't prove that E equals mc squared, i.e. in the context he didn't derive it from special relativity, he just magically made it appear. Article does note, in 1900 the ubiquitous Henry Poincaré stated that if one required that the momentum of any particle present in an electromagnetic field plus the momentum of the field itself can be conserved, then Poincaré's theorem predicted that the field acted as a fictitious fluid with mass such that E equals mc squared. Poincaré, however, failed to connect E with the mass of any real body. So that's noting that the equation E equals mc squared was around 1900, and that was before Einstein stated it in 1905. So it's around at least 5 years before Einstein. So are we supposed to be going by what Poincaré was saying in 1900 or not? Well, we seem to be going by what Einstein says, and what Einstein says, where he just brings the equation into existence magically. The article goes on to say other things, but the main points that I want to make have been made. Here's Einstein. Einstein does not derive E equals mc squared from special relativity. Those people who think it comes in special relativity and hence are impressed that the equation comes in special relativity have it wrong. Einstein makes the equation E equals mc squared appear by magic. Hey presto, abracadabra. And so that's the end of this short video. E equals mc squared. Well, Einstein says E equals mc squared, but it's not really that impressive because he just makes it appear by magic. And people before him have also tried to consider the possibility of energy and maths being related. And Einstein just does not add anything extra to that. He doesn't derive the equation from his theory or anything. If you could just add it ad hoc to Newtonian physics. And thank you, that's the end of this little talk.